This is our first practice. There are going to be two for your Unit 4, Topic 2, assessment number 3. We have a table of values that represent Superman as he flies off of a ledge, down to ground level, tunnels underground, grabs Lois, and then returns her up to the ledge where she's safe. First, let's look at the table and see what type of function we are dealing with. In these y values, from 32 to 21 goes down 11, 21 to 12 goes down 9, then down 7. So as we should have expected probably with what we've been dealing with, we see our first differences are linear, which means this is a quadratic function, okay? Now, the problem is in that table of values, I don't see anything that indicates where the vertex is. Is it one of those numbers? Have I not seen it yet? Is it at some middle? Is it at some irrational or decimal number that's in between what I'm seeing in the table? And you don't have that information, okay? So I'm not going to be able to jump right into the vertex form. I have one x-intercept, but I don't know if there is another one. I don't know if I just haven't seen it yet in the table, if it comes later. So I can't jump right to factored form either. That means we should find our standard form first. Hopefully, you will use your calculator and use the quad reg feature. But if not, I'm going to go through this process again. I've done it once or twice before. You're not required to know it, but it's interesting. Okay? So standard form, y equals ax squared plus bx plus c. I can pick a couple of those things out from this table of values. Okay? The a is half of the second difference. Well, I didn't record my second differences here, but I can. It'll only take a minute. So from negative 11 to negative 9 is up 2, and so on. So I know that half of the second difference, so positive 1, is a. So in my equation so far, I have y equals 1 x squared plus bx, and then plus I can also identify the c value from the y-intercept. So c is 32. Now if I just had the b value, I'd be set, I'd be done. But I don't have that. So in this case, if we're not using a calculator, the way we find that b value is pick one point out of the table, any point, and substitute it in for x and y. I am going to choose I can't use, I say any point. I can't use the 0.32 because that will cancel out the b value, and b is what I'm solving for. So maybe I'll pick the 121. Right? That means the y value is 21 every time x is 1. All right, so let's simplify the right-hand side here. 1 squared is 1, times another 1 is 1, plus 1b is b, plus 32. Well, 1 plus 32 is 33 plus b. So subtract 33, and I find out my b is negative 12. Okay? So I can go ahead and say now that I know my standard form of the equation has a negative 12 as the b. So it's 1x squared minus 12x plus 32. All right, once I have the standard form, I can use that to develop my vertex form. So I'll bring over my standard form, x squared plus 12x plus 32. All right, well, we had to split the negative 12. Negative 12 divided by 2 is negative 6, and then square that. So 36. That means I want this number here to be a 36. Well, in order for it to be a 36, I'm going to have to add 4. But I can only add 4 if I also subtract 4. So this really becomes y equals x squared minus 12x plus the 36. That's what I wanted to have. And I'm required to have a minus 4 to make up for that. Well, this, because we designed it that way, is a perfect square trinomial, meaning I can factor it as x minus, because the 12 is negative, 6, because that's both half of 12 and the square root of 36, minus 4. And there is my vertex form. Now, it turns out that we did have the vertex 6, negative 4 in the table, we just didn't know it. Had there been one more point in the table, it would have been 7, negative 3, which would start that symmetrical pattern, and you would have been able to identify that as a vertex. But we did not start with that. Factored form, I need to go, again, back to my standard, y equals x squared minus 12x plus 32, and that's the one I'll try to factor. First, I look for a GCF. I don't have one. So I jump to the magic x. 1 times 32 is 32. That's the product I'm looking for. The middle term, negative 12, will be the sum. Since the product is positive, I need 2 of the same sign. Since this is negative, they both have to be negative. Factors of 32 that add up to 12 are 4 and 8. So y is equal to x minus 4 and x minus 8. Again, that does match the one x-intercept I was given in the table. It was 4, so I knew this factor. I just didn't have the x minus 8. All right, there's your 3 forms. Notice that the grid says use it if you want to graph. I don't see any reason to do that. What are the values of the x-intercepts of his flight path, and what do they mean? Because that factored form was y equals x minus 4 times x minus 8, the x-intercepts are 4 and 8. Now there is a second part. What do they mean in this context? So as far as Superman and Lois Lane are concerned, 4 and 8, those are the 2 times where Superman is at ground level, at height 0. So what that means is he, flying from the ledge, he first hit the ground at 4 seconds, then he proceeded underneath, grabbed Lois, and he burst back up out of the ground at exactly 8 seconds. Which quadratic form would be most efficient? The factored form, of course. What are the coordinates of the vertex, and what does it tell you about Superman's flight? Well, the vertex was 6, negative 4. What does that tell you about the flight? Superman reached his minimum height, or his lowest, his furthest underground, was at his minimum height. Okay, so 4 feet below the surface at 6 seconds. This is the point that he grabs Lois. You could explain that a few different ways, but you need to say more than just it's the vertex. It's where he stops moving down and starts flying up. It's where he grabs Lois. It's where it took him 6 seconds to get to Lois, and she was 4 feet below the surface, something like that. Which quadratic form would be most efficient for answering that? Okay, the vertex form, of course. What is the equation of the line of symmetry, and what does it tell you about Superman's flight? Remember, equation for the line of symmetry is always x equals the first coordinate of the vertex, so x equals 6. All right, so what does it tell me? Well, it's the halfway point. All right, 6 seconds is the halfway point of the flight, of the rescue. The axis of symmetry is always splitting your parabola into 2 congruent halves. So 6 seconds is exactly the halfway point. You could say 6 seconds is After 6 seconds, he stops flying down and starts to fly up. He stops decreasing and starts increasing. So according to the quadratic model, how long did it take Superman to save Lois and return to the ledge? And how do we know that? Well, in our next topic, you will learn how to put in a desired value for the y and solve that equation, but we haven't done that yet. There must be a simpler way to answer this. Well, remember, the ledge is where he started. The ledge, he was there in the beginning at 32 feet. Think about the answer we just gave up here at number 6. 6 seconds was exactly the halfway point. Well, because every parabola is symmetrical, it's just going to take another 6 seconds to get back where he started, right? If the first half takes 6 seconds, the second half takes 6 seconds. The entire rescue takes 12 seconds, and we know because 6 seconds marked the halfway point, and every parabola is symmetrical, it will take another 6 seconds to return to the ledge. Just use the fact that you knew when you were halfway, double that, you're all the way.